A voltage imbalance in a 120/240 volts residential electrical system can manifest as dim lights or erratic behavior of electrical devices. Diagnosing the root cause requires a systematic approach. Several factors can contribute to this issue, and it is important to know about it. Firstly, a loose neutral connection is a common culprit. The neutral connection is critical for providing a return path for current and maintaining a balanced voltage across the phases. A loose connection at the neutral bus or a broken neutral wire can disrupt this balance, leading to one phase with a lower voltage and the other with a higher voltage. This imbalance becomes more pronounced when loads are applied. Secondly, a faulty transformer winding can also cause voltage imbalances. The transformer is responsible for stepping down the high voltage from the utility lines to the usable 120/240 volts for the home. If a transformer winding is failing or has an internal short, it can result in uneven voltage distribution. Thirdly, heavy load on one phase can lead to a voltage drop on that phase and a corresponding increase on the other phase. This is because the transformer has a limited capacity and excessive current draw on one side can affect the voltage regulation. Fourthly, a ground fault on the neutral can create a parallel path for current, diverting it away from the intended circuit and leading to voltage imbalances. This can be a dangerous situation, as it can also create a shock hazard. Fifthly, an open neutral transformer terminal can break the neutral path, causing severe voltage imbalances. This is often a result of corrosion or physical damage to the terminal. Here are the troubleshooting steps. Firstly, check the neutral connections. Inspect the neutral bus and connections at the service panel, meter base, and any subpanels to ensure they are tight and secure. Look for signs of corrosion, arcing, or loose wires. Use a screwdriver or a wrench to tighten any loose connections. Secondly, test for neutral continuity. Use a multimeter to check the continuity between the neutral bus and a grounding electrode, such as a grounding rod or metal water pipe. A lack of continuity indicates a break in the neutral path. The multimeter should be set to the ohm setting. A reading of 0 ohms or close to 0 ohms indicates good continuity. A reading of infinity or a very high resistance indicates a break in the neutral path. Thirdly, verify the transformer winding integrity. Test the transformer windings for continuity and resistance using an ohm meter. Compare the results with manufacturer's specifications. Discrepancies can indicate a faulty transformer. To test the transformer windings, disconnect the power to the transformer. Set the multimeter to the ohm setting. Place the multimeter probes across each winding of the transformer. Compare the resistance readings with the manufacturer's specifications. If the readings are significantly different, the transformer may be faulty. Fourthly, check for heavy loads. Determine if any large or unusual loads are connected to the system. Disconnect any non-essential loads and observe the voltage balance. If the voltage returns to normal after disconnecting a particular load, that load may be the source of the imbalance. Fifthly, inspect for ground faults. Use a ground fault detector or circuit tester to check for any ground faults in the neutral wire. This can help identify any unintentional current paths. A ground fault detector works by measuring the current flowing through the grounding wire. If there is a ground fault, the detector will indicate that current is flowing through the grounding wire. A circuit tester can be used to test for ground faults in individual circuits. Sixthly, contact the utility company. If all troubleshooting measures fail, consider contacting the utility company to investigate the transformer and distribution lines. The utility company has specialized equipment and expertise to diagnose and repair problems on their side of the system. Regarding additional considerations, in the absence of any ground faults or loose connections, a faulty transformer is the most likely culprit. If the voltage imbalance persists even with no loads, it indicates a problem with the transformer or distribution system. Always use proper safety precautions when troubleshooting electrical systems. Wear appropriate personal protective equipment such as insulated gloves and safety glasses. Work in a well-lit area and avoid working alone. If you are not comfortable working with electricity, contact a qualified electrician. Voltage imbalance is a serious issue that can damage electrical equipment and pose a safety hazard. By following these troubleshooting steps, you can identify the cause of the imbalance and take corrective action. Here are some additional details on how to troubleshoot voltage imbalances. When checking neutral connections, pay close attention to the connections at the service panel. The service panel is where the main power enters the home and is a common location for loose connections. Also, check the connections at the meter base. The meter base is where the utility company's meter is located and is another common location for loose connections. Furthermore, check the connections at any subpanels. Subpanels are smaller electrical panels that are located throughout the home. They are often used to supply power to specific areas, such as the kitchen or bathroom. When testing for neutral continuity, make sure to disconnect the power to the circuit before testing. This will prevent you from getting an electrical shock. When verifying transformer winding integrity, make sure to use a multimeter that is rated for the voltage of the transformer. Using a multimeter that is not rated for the voltage can damage the multimeter and potentially cause an electrical shock. When checking for heavy loads, consider the time of day. Some loads, such as air conditioners and electric heaters, draw more power during certain times of the day. When inspecting for ground faults, start by checking the outlets and appliances that are closest to the service panel. Ground faults are more likely to occur closer to the service panel. If you are unable to find the cause of the voltage imbalance, it is best to contact a qualified electrician. An electrician has the experience and training to diagnose and repair complex electrical problems. Remember that safety should always be your top priority when working with electricity. If you are not comfortable working with electricity, contact a qualified electrician. Let's talk about how to use a multimeter, an essential tool for electrical troubleshooting. To measure voltage, firstly, set the multimeter to the alternating current volts setting. Secondly, connect the black lead to the common terminal and the red lead to the volts terminal. Thirdly, place the probes across the points you want to measure the voltage. To measure resistance, firstly, set the multimeter to the ohms setting. Secondly, disconnect the power to the circuit. Thirdly, connect the black lead to the common terminal and the red lead to the ohms terminal. Fourthly, place the probes across the component you want to measure the resistance. To measure continuity, firstly, set the multimeter to the continuity setting, often indicated by a diode symbol or a sound wave symbol. Secondly, disconnect the power to the circuit. Thirdly, connect the black lead to the common terminal and the red lead to the volts terminal. Fourthly, place the probes across the points you want to test for continuity. If there is continuity, the multimeter will beep or display a low resistance reading. A common misconception is that grounding is the same as the neutral. While both are essential for safety, they serve different purposes. The neutral provides a return path for current under normal operating conditions, while the ground provides a path for current in the event of a fault, such as a short circuit. The grounding system is designed to trip the circuit breaker or fuse, preventing electrical shock. Therefore, grounding cannot completely substitute for a faulty neutral in all situations, especially concerning voltage imbalances. Let's also consider the scenario where the voltage imbalance occurs only when specific appliances are turned on. This suggests that the appliance itself might be faulty or drawing excessive current. In this case, try disconnecting the appliance and observing whether the voltage imbalance disappears. If it does, then the appliance is likely the problem. However, if the voltage imbalance persists even with all appliances disconnected, then the problem is likely in the wiring or the transformer. It is also worth checking the size of the service entrance conductors. If the conductors are too small for the load, they can cause a voltage drop, especially when multiple appliances are running simultaneously. The size of the service entrance conductors should be adequate for the calculated load of the house, according to the National Electrical Code, NEC Table 310.15b16. To determine the appropriate size, you need to calculate the total load of the house, including lighting, appliances, and other electrical equipment. The NEC provides guidelines for calculating the load based on the square footage of the house and the types of appliances used. Once you have calculated the total load, you can use NEC Table 310.15b16 to determine the minimum size of the service entrance conductors. If the existing conductors are too small, they should be replaced with larger conductors. Also note that some appliances, such as electric vehicle chargers, can draw a significant amount of current. If you are planning to install an electric vehicle charger, you need to make sure that the service entrance conductors are large enough to handle the additional load. Another important consideration is the type of wiring used in the house. Older homes may have aluminum wiring, which can be more prone to corrosion and loose connections than copper wiring. If you have aluminum wiring, it is important to have it inspected by a qualified electrician to ensure that it is safe and in good condition. Aluminum wiring requires special connectors and antioxidant compounds to prevent corrosion. The electrician should also check the connections at the outlets and switches to make sure they are tight. If you are experiencing voltage imbalances, it is also a good idea to have the entire electrical system inspected by a qualified electrician. The electrician can identify any potential problems and make recommendations for repairs or upgrades. A whole house surge protector can help protect your electrical equipment from voltage spikes and surges. Voltage spikes and surges can damage sensitive electronic equipment such as computers, televisions, and appliances. A whole house surge protector is installed at the service panel and protects all of the electrical equipment in the house. It is also important to protect yourself from electrical shock when working with electricity. Always disconnect the power before working on any electrical circuit. Use insulated tools and wear rubber gloves and safety glasses. If you are not comfortable working with electricity, contact a qualified electrician. Furthermore, be aware of the signs of a faulty electrical system such as flickering lights, burning smells, and sparking outlets. If you notice any of these signs, contact a qualified electrician immediately. Remember, electricity can be dangerous if not handled properly. Always take safety precautions when working with electricity. Ensure all electrical work complies with local electrical codes and regulations. Local codes often have specific requirements for wiring methods, grounding, and overcurrent protection. Obtain the necessary permits and inspections for any electrical work to ensure compliance with the codes. This helps to ensure the safety of the electrical system and protects the property from fire and other hazards. It is also important to keep electrical panels and equipment accessible for maintenance and repairs. Do not block access to electrical panels with furniture or other items. Also, keep the area around electrical equipment clean and free of debris. Regular maintenance of electrical equipment can help to prevent problems and extend the life of the equipment. This includes checking connections, cleaning components, and testing the operation of the equipment. A qualified electrician can perform regular maintenance on your electrical system. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Bonding connects all metal parts of the electrical system together, creating a common ground potential. Make sure that the grounding and bonding system is properly installed and maintained. The grounding electrode conductor should be properly sized and connected to the grounding electrode. The bonding jumpers should be properly sized and connected to all metal parts of the electrical system. Consider the impact of adding new electrical loads to the system. Adding new appliances, equipment, or circuits can increase the load on the electrical system. Make sure that the electrical system is capable of handling the additional load. You may need to upgrade the service entrance conductors, the service panel, or the branch circuits to accommodate the new load. A load calculation can help to determine the total load on the electrical system. Also, be aware of the limitations of extension cords and power strips. Extension cords and power strips are designed for temporary use only. Do not use them as permanent wiring. Overloading extension cords and power strips can cause overheating and fire. Use extension cords and power strips that are rated for the amount of current that you will be using. Inspect extension cords and power strips regularly for damage. Replace any damaged extension cords or power strips. Lightning strikes can cause severe damage to electrical systems. Lightning can enter the electrical system through the power lines, the telephone lines, or the cable television lines. A lightning surge protector can help to protect your electrical equipment from lightning strikes. Lightning surge protectors are installed at the service panel and protect all of the electrical equipment in the house. In summary, troubleshooting voltage imbalances requires a systematic approach, attention to detail, and a strong emphasis on safety. When in doubt, always consult with a qualified electrician.